In 1990, a Boston University geologist stood before the Great Sphinx of Giza and noticed something that would ignite one of archaeology's most explosive controversies: deep vertical grooves carved into ancient limestone, erosion patterns that could only be caused by one thing: heavy, prolonged rainfall. But here's the problem that Egyptologists desperately want to ignore. The Sahara Desert hasn't experienced rainfall heavy enough to create this erosion in over 12,000 years. That means the Sphinx, officially dated to 2500 BCE, just 4,500 years ago, might actually be more than twice as old as the pyramids themselves. It means a sophisticated civilization existed before recorded history. And it means everything we've been taught about human origins might be wrong. Tonight, as you drift into sleep, we're diving into geological evidence, hidden chambers detected 2,000 feet beneath the monument, and the academic war that's been raging for over 3 decades. This is the Sphinx water erosion mystery, the discovery that could rewrite human history. Before we journey back 12,000 years, do me a favor. Subscribe to Deep Sleep Documentary and hit that notification bell. Every night, we explore history's most controversial mysteries, the stories mainstream academia doesn't want you questioning. Over 285 fellow truth seekers have already joined our community of curious minds. Now, close your eyes, get comfortable, and let's uncover what's really hidden beneath the sands of Egypt. Dr. Robert Schoch wasn't looking to start a revolution. He was simply asked to disprove a theory. In the spring of 1990, Schoch received an unusual invitation from John Anthony West, an independent Egyptologist who had spent years studying the monuments of ancient Egypt outside the traditional academic establishment. West had developed a controversial theory based on observations made decades earlier by the French mathematician and philosopher R.A. Schwaller de Lubitsch during his studies in Egypt in the 1950s. The theory was simple but explosive. The Great Sphinx showed clear signs of water erosion, which meant it had to be far older than mainstream archaeology claimed. West needed a credentialed geologist to examine the evidence, someone with the scientific background to either confirm or debunk what he was seeing in the weathering patterns of the limestone. He needed someone who had no preconceived agenda, no career invested in either supporting or opposing the conventional dating of Egyptian monuments. Robert Schoch, a respected professor of geology and geophysics at Boston University, fit that profile perfectly. His specialty was examining rocks and weathering patterns, not Egyptian history. He had no particular interest in alternative archaeology or ancient mysteries. When West approached him, Schoch was actually skeptical of the entire proposition. The invitation was straightforward and appealing in its scientific simplicity. West told Schoch, "Just look at the rocks and tell me what you see. Don't worry about the history, the Egyptology, the implications. Just examine the geological evidence with your trained eye and give me your professional opinion as a geologist." For Schoch, this seemed like an interesting consulting opportunity, a chance to visit Egypt, and frankly, he expected to quickly dismiss West's theory and move on with his career. He had no idea he was about to step into one of the most contentious debates in modern archaeology. When Schoch arrived at the Giza Plateau and stood before the Great Sphinx for the first time, he approached it as he would any geological formation. He examined the limestone carefully, studying the weathering patterns, the erosion channels, the overall condition of the stone. And almost immediately, he recognized something that troubled him deeply as a scientist. The erosion patterns he was seeing didn't match what he would expect from a monument that had been exposed to 4.5 millennia of desert wind and sand. They matched something entirely different. The vertical grooves carved into the Sphinx's body were deep, in some places more than 2 feet deep, creating a wave-like pattern of channels and ridges across the limestone surface. This type of weathering is characteristic of precipitation runoff, of water flowing down over stone for extended periods. Wind and sand erosion, which is what you would expect in a desert environment, creates horizontal weathering patterns, a smoothing and rounding effect as abrasive particles are blown across the surface. What Schoch was looking at was categorically different. It was the unmistakable signature of water erosion, specifically rainfall runoff that had cascaded down the monument's sides for thousands of years. But the evidence became even more compelling when Schoch began comparing the Sphinx to other structures on the Giza Plateau that were supposedly carved during the same period. The tombs and temples that mainstream Egyptology dates to the 4th dynasty, the same era as the Sphinx according to official chronology, showed minimal erosion. Their limestone was relatively pristine compared to the deeply weathered body of the Sphinx. If all these monuments had been carved around 2500 BCE and exposed to the same desert climate for the same length of time, they should show similar weathering patterns. They didn't. Schoch examined the limestone composition itself, analyzing whether variations in stone quality could explain the differential weathering. The Sphinx was carved from the natural limestone bedrock of the Giza Plateau, and yes, there were variations in the stone's hardness and density throughout the monument, but these variations couldn't account for the type of erosion pattern he was observing. Softer limestone erodes faster than harder limestone, certainly, but the fundamental character of the erosion, whether it's caused by wind, sand, or water, remains consistent. What he was seeing indicated prolonged exposure to significant rainfall, period. The head of the Sphinx, Schoch noted, showed different weathering patterns than the body. It was less eroded, which initially seemed puzzling, until he considered that the head had likely been recarved at some point in antiquity, possibly during one of the many restoration projects that Egyptian pharaohs had undertaken over the millennia. This would explain why the head appears proportionally smaller than the massive leonine body. It wasn't originally carved that way. Someone had reworked it, cutting away more limestone and giving it a different shape, probably a pharaoh's face, which removed the older weathered surface. As Schoch spent more time examining the monument and consulting geological literature on weathering patterns in different climates, he kept arriving at the same conclusion. The scientific evidence was pointing to something that seemed archaeologically impossible. For the Sphinx to show this degree of water erosion, it would need to have been exposed to a climate with regular, heavy rainfall for thousands of years. The Sahara Desert region hasn't experienced that kind of climate in recorded history. You would have to go back to before the end of the African humid period, before the Sahara became a desert, to find the climatic conditions necessary to create this weathering pattern. Schoch ran the calculations, consulted with other geologists about weathering rates in limestone, and examined paleoclimatological data about North African rainfall patterns over the past 15,000 years. Every avenue of research led to the same uncomfortable conclusion. The Great Sphinx of Giza had to be at least 7,000 to 9,000 years old, possibly older. It had to have been carved during a period when the Sahara was still green, when regular monsoon rains swept across North Africa, when the climate was fundamentally different from today. That placed its construction somewhere between 10,000 and 7,000 BCE, pushing the monument back into the end of the last ice age or the early post-glacial period. This was revolutionary and deeply problematic. According to mainstream archaeology, complex civilization didn't exist anywhere on Earth at that time. Humans were supposedly living in small hunter-gatherer groups, barely beginning to experiment with agriculture in a few scattered locations. The idea that someone was carving massive monuments out of solid bedrock, monuments that required sophisticated engineering, organization, and stoneworking skills, simply didn't fit the accepted narrative of human development. Schoch knew that what he was about to announce would be controversial, but he was a scientist, and the rocks don't lie. In 1991, Schoch presented his findings at the annual meeting of the American Association for the Advancement of Science. He chose his words carefully, presenting the geological evidence methodically and avoiding sensationalism. He didn't claim to know who built the Sphinx, or why. He simply stated what the rocks were telling him. The Great Sphinx of Giza shows clear evidence of water erosion, requiring prolonged exposure to significant rainfall. And based on geological analysis and paleoclimatological data, the monument is at least 7,000 to 9,000 years old, possibly older than 10,000 years. It may have been carved during the African humid period when the Sahara was still capable of supporting complex societies. The response from the Egyptological establishment was immediate and hostile. This wasn't a scientific debate about weathering patterns and erosion rates. This was warfare. Schoch had challenged one of the foundational dates in Egyptian chronology, and by extension, he had challenged the entire framework of how we understand the development of human civilization. If he was right, it meant that mainstream archaeology had been wrong about something fundamental for over a century. It meant that complex engineering and stoneworking capabilities existed thousands of years before the first cities of Mesopotamia, before the invention of writing, before everything we thought marked the beginning of civilization. Shaka's credentials made him difficult to dismiss. He wasn't a fringe theorist or an amateur enthusiast. He was a respected geologist from a major university, publishing peer-reviewed research and using standard scientific methodology. His analysis of the Sphinx was based on well-established geological principles, the same principles used to date rock formations and weathering patterns all over the world. But none of that mattered to the gatekeepers of Egyptian archaeology. They had a timeline to protect, and Shaka's geological evidence threatened to dismantle it. The response from mainstream Egyptology wasn't scientific debate, it was warfare. Dr. Zahi Hawass, Egypt's most prominent archaeologist, and at various times the Secretary General of the Supreme Council of Antiquities, dismissed Shaka's findings with barely concealed contempt. Impossible, ridiculous, American hallucinations, he declared in multiple interviews and public statements. Hawass didn't engage with the geological evidence itself. He simply rejected the conclusion because it contradicted the established chronology of Egyptian history, a chronology that had been built up over more than a century of archaeological work, and that he had dedicated his career to defending and promoting. Dr. Mark Lehner, an Egyptologist with extensive experience excavating and studying the Giza Plateau, mounted a more detailed counter-argument. Lehner had worked at Giza for decades and knew the monuments intimately. His rebuttal focused on offering alternative explanations for the erosion patterns that Shok had identified as evidence of water weathering. Lehner argued that the vertical grooves could have been caused by wind-driven sand over long periods, that the differential weathering between the Sphinx and nearby tombs could be explained by variations in limestone quality, and the periodic flooding from the Nile during the Old Kingdom could have contributed to water damage on the monument. Lehner also pointed to chemical weathering caused by humidity and morning dew as a possible explanation for some of the erosion features. The Giza Plateau experiences significant temperature fluctuations between day and night, and moisture from humidity and dew can penetrate limestone and cause chemical breakdown of the stone over time. This process, combined with salt crystallization and expansion within the rock's pores, could theoretically create weathering patterns that might be mistaken for rainfall erosion by someone not intimately familiar with the specific microclimate of the Giza Plateau. The mainstream counterarguments emphasized that the limestone comprising the Sphinx body was not uniform in composition or quality. Different layers of the bedrock had different densities, different levels of hardness, and different susceptibilities to erosion. The lower portions of the Sphinx, carved from softer limestone layers, naturally eroded faster than the upper portions carved from harder stone. This differential erosion, Lehner argued, could create the appearance of deep vertical channels without requiring thousands of years of rainfall. It was simply the natural result of softer stone weathering more rapidly under the same environmental conditions. But there was more than just scientific disagreement at play in this controversy. There was a political and cultural dimension that couldn't be ignored. Egyptian national pride was deeply invested in the achievements of the pharaonic civilization. The pyramids, the Sphinx, the temples and tombs of the Nile Valley represented one of humanity's greatest archaeological legacies, and that legacy belonged to Egypt. The notion that the Sphinx might have been carved by some unknown pre-dynastic culture, or worse, by a lost civilization that preceded Egyptian history, was seen as an attempt to diminish Egyptian achievement and credit Egypt's most iconic monument to mysterious foreigners or prehistoric peoples who had no connection to the land. Hawass, in particular, framed the debate in nationalistic terms, portraying Shok and other proponents of the water erosion theory as Western academics trying to steal Egypt's heritage. He suggested that accepting an earlier date for the Sphinx would play into colonialist narratives that ancient Egyptians couldn't have achieved such remarkable engineering feats on their own, that they must have received help from some earlier, more advanced civilization. This rhetorical strategy was effective in rallying Egyptian public opinion against the water erosion theory, even though Shok himself had never made any claims about who carved the Sphinx, or suggested that it wasn't created by indigenous North African peoples. The academic gatekeeping that followed Shok's announcement was systematic and severe. When he applied for permits to conduct additional research at Giza, to take core samples from the Sphinx enclosure for detailed geological analysis, to perform more comprehensive surveys of the weathering patterns, his applications were denied. The Egyptian authorities, advised by Hawass and other establishment Egyptologists, effectively blocked him from gathering the additional evidence that could further support or refine his conclusions. This wasn't unusual treatment for someone challenging orthodoxy in Egyptian archaeology, but it prevented the scientific process from moving forward in the way it should. Peer-reviewed archaeology journals rejected papers on the water erosion theory, not because of flaws in the geological methodology, but because the conclusions were deemed too controversial and incompatible with the established chronology. When Shach presented his findings at academic conferences, he was often met with hostility rather than genuine scientific inquiry. Questions from the audience weren't about weathering rates or erosion patterns. They were challenges to his audacity in questioning what every Egyptologist knew to be true about the age of the Sphinx. The message was clear. This line of research was unwelcome, and pursuing it would have professional consequences. For younger academics who might have been intrigued by Shach's evidence and interested in pursuing related research, the risks were obvious. Egyptian archaeology is a small field, highly specialized, and heavily dependent on access to sites in Egypt. If the Egyptian authorities wouldn't grant you permits, your career in the field was essentially over. If senior Egyptologists viewed you as a supporter of fringe theories, you wouldn't get tenure, wouldn't get published in the major journals, wouldn't be invited to the important conferences. The institutional pressure to conform to the accepted timeline was immense, and most academics understandably chose career survival over controversy. This raises an important question that extends beyond the specifics of the Sphinx debate. Why such extreme resistance to geological evidence? If Shach's analysis was flawed, if the erosion patterns really could be explained by wind and sand and humidity, then presenting that counter-evidence should have been sufficient. The scientific community is accustomed to debates about dating and interpretation. Arguments about whether a particular site is 500 years older or younger than previously thought are common and generally don't provoke this kind of hostile response. But the Sphinx water erosion theory struck at something more fundamental, and the response suggested that more than just academic disagreement was at stake. The official dating of the Sphinx rests primarily on Egyptological interpretation rather than direct physical evidence. There are no inscriptions on the Sphinx itself, identifying who carved it or when. The attribution to Pharaoh Khafre of the 4th dynasty, who ruled around 2500 BCE, is based largely on circumstantial evidence and assumptions about the relationship between the Sphinx and the nearby pyramids. The most concrete piece of evidence cited is the Dream Stele, a granite tablet placed between the Sphinx's paws by Pharaoh Thutmose IV around 1400 BCE, more than 1,000 years after Khafre's reign. The Dream Stele describes how Thutmose, while still a prince, fell asleep near the Sphinx during a hunting expedition. In his dream, the Sphinx spoke to him, promising that he would become pharaoh if he cleared away the sand that had buried the monument. Thutmose fulfilled this promise after ascending to the throne, and the stele commemorates his restoration work. The damaged inscription on the stele includes what appears to be part of Khafre's name, which Egyptologists have interpreted as indicating that Khafre was the original builder. But this interpretation is problematic for several reasons. First, the stele was erected more than 1,000 years after Khafre's death. It's a retrospective account, not a contemporary record. Second, the portion of the inscription that supposedly names Khafre is damaged and incomplete, and the reconstruction of the missing hieroglyphs requires assumptions. Third, even if the stele does reference Khafre, it doesn't necessarily mean he built the Sphinx. He might have renovated it. Or the stele might simply be noting that the Sphinx was already ancient during his reign. The Dream Stele describes the Sphinx as being buried in sand up to its shoulders when Thutmose found it, suggesting the monument had been neglected for a very long time, which raises questions about how well its origins were remembered, even in the New Kingdom. There are no contemporary 4th dynasty inscriptions directly linking Khafre to the construction of the Sphinx, no tomb paintings showing its carving, no papyri documenting the project, no administrative records of the workers involved. The attribution is based primarily on the assumption that the Sphinx was carved at the same time as the nearby pyramid complex, and since that complex is attributed to Khafre, the Sphinx must also be his work. But this is circular reasoning. We know the Sphinx dates to Khafra's reign because it's part of his complex, and we know it's part of his complex because it dates to his reign. The relationship between the Sphinx and Khafra's pyramid complex is itself ambiguous. The Sphinx Temple and Valley Temple, which are directly adjacent to the Sphinx, are constructed using massive limestone blocks, some weighing over 200 tons, with a distinctive architectural style that some researchers argue is different from typical 4th dynasty construction. The precision of the stonework, the lack of inscriptions, and the evidence of later modifications by known pharaohs have led some scholars to suggest that these temples might predate the pyramid complex and were renovated rather than built by Khafra. If you step back and look at the evidence objectively, what you find is a remarkable absence of definitive proof for the conventional dating. You find assumptions built on other assumptions, interpretations that serve to reinforce an existing chronology rather than challenge it. You find a scholarly consensus that is hardened into dogma, defended not through scientific debate, but through institutional gatekeeping and professional pressure. And you find legitimate geological evidence that contradicts this consensus being dismissed, not because it's been disproven, but because accepting it would require too many other revisions to the established narrative. The academic resistance to the water erosion theory reveals something important about how institutional science operates when confronted with paradigm-threatening evidence. Thomas Kuhn, the philosopher of science, described how scientific revolutions occur not through the gradual accumulation of contradictory evidence, but through sudden shifts when the weight of anomalies becomes too great to ignore. Before that shift happens, there's typically a period of fierce resistance where the old paradigm's defenders dismiss, ignore, or explain away the anomalies. That's exactly what we're seeing with the Sphinx debate. The geological evidence is an anomaly that doesn't fit the chronological paradigm, and rather than seriously engaging with it, the establishment has chosen to defend the paradigm. To understand if water carved the Sphinx, we need to answer one question. When was the Sahara green? This isn't speculation or alternative history. This is established climate science, documented through multiple lines of evidence from paleoclimatology, archaeology, and geology. The Sahara Desert, the largest hot desert on Earth today, covering most of North Africa with seemingly endless expanses of sand and rock, was once a completely different landscape, and not that long ago in geological terms. Between approximately 15,000 BCE and 5,000 BCE, North Africa experienced what scientists call the African humid period, also known as the Holocene wet phase. During this extended epoch, the region that is now the Sahara Desert received regular monsoon rains, supported vast grassland savannas, contained numerous permanent lakes and rivers, and was home to abundant wildlife and human populations. This wasn't a brief anomaly or a minor climate fluctuation. This was thousands of years of fundamentally different environmental conditions that shaped the entire region. The evidence for the African humid period is overwhelming and comes from multiple independent sources. Lake sediment cores drilled from former lake beds across the Sahara show layers of organic material, pollen, and microscopic aquatic organisms that could only have existed in permanent bodies of water. These sediment layers are sandwiched between older and younger layers of desert sand, providing a clear geological record of when the region was wet and when it became dry. The transition isn't gradual. The sediment layers show a relatively rapid shift from humid conditions to arid conditions around 5,500 to 5,000 BCE. One of the most dramatic pieces of evidence is Lake Megachad, a massive body of water that covered approximately 150,000 square miles in what is now Chad, Niger, and Nigeria during the peak of the African humid period. This ancient lake was larger than the Caspian Sea, the world's largest lake today. Shoreline deposits, beach ridges, and sediment layers from Megachad have been mapped and dated, showing that the lake reached its maximum extent around 8,000 to 6,000 BCE. When the climate shifted and rainfall declined, this enormous lake gradually shrank to become Lake Chad, which today covers less than 1,000 square miles and continues to shrink as the Sahara expands. The rock art of the Sahara provides vivid testimony to how different the environment once was. Across the desert, in places like the Tassili N'Ajjer Plateau in Algeria, the Tibesti Mountains in Chad, and the Caucasus Mountains in Libya, ancient peoples left thousands of paintings and engravings on rock walls. These artworks, some dating back more than 10,000 years, depict scenes of daily life in a landscape that bears no resemblance to the modern Sahara. The images show giraffes, elephants, hippopotamuses, crocodiles, antelopes, and other animals that require permanent water sources and grassland habitats. They show people herding cattle, fishing in rivers, and hunting in environments that were clearly savanna or woodland rather than desert. Some of the rock art shows boats and scenes of people traveling on water, indicating that rivers and lakes were common features of the landscape. The distribution of these rock art sites across the Sahara maps closely to what were once river valleys and lake basins during the humid period. The artistic skill and cultural sophistication displayed in the paintings suggest that these weren't scattered bands of struggling nomads, but organized societies with leisure time, cultural practices, and probably seasonal settlements near water sources. When the climate changed and the rains failed, these people either adapted, migrated toward remaining water sources like the Nile Valley, or perished. The shift from humid to arid conditions wasn't caused by random chance. It was driven by predictable, cyclical changes in Earth's orbital parameters, known as Milankovitch cycles. These cycles involve three main components: the eccentricity of Earth's orbit around the Sun, the tilt of Earth's axis, and the precession of the equinoxes. These orbital variations operate on timescales of tens of thousands of years and cause significant changes in the amount and distribution of solar radiation received at different latitudes and seasons. Around 15,000 years ago, orbital configurations favored stronger summer monsoons in North Africa. The increased solar radiation during Northern Hemisphere summers strengthened the African monsoon system, drawing moist air from the Atlantic and Indian Oceans deep into the continental interior. This brought regular seasonal rainfall to regions that had been arid during the last glacial maximum. As Earth's orbital parameters gradually shifted, the summer monsoons weakened, rainfall declined, and the region slowly transformed back into desert. The process wasn't instantaneous, but it also wasn't indefinitely gradual. Climate records show that the transition to fully arid conditions happened relatively quickly in geological terms, over a few centuries rather than millennia. The peak rainfall during the African humid period occurred roughly between 10,000 and 8,000 BCE, which is exactly when Robert Schoch's geological analysis suggests the Sphinx must have been carved to show the degree of water erosion visible today. This isn't a coincidence that Schoch retrofitted his conclusions to match. The climate data existed independently of his geological analysis. When he calculated how long the observed erosion patterns would take to develop under conditions of regular rainfall, and then compared that timeline to paleoclimatic records of when North Africa actually experienced regular rainfall, the two completely independent lines of evidence aligned. This creates a serious timeline problem for the mainstream Egyptological position. If the Sphinx was carved around 2500 BCE, as conventionally dated, it would have been carved after the African humid period had ended, after the Sahara had already become predominantly desert. The heavy rainfall necessary to create the deep vertical erosion channels that Schoch documented would not have been occurring in 2500 BCE. The climate by that time was already similar to today's: hot, dry, with minimal precipitation. Wind and sand would have been the dominant erosion factors, not water. Mainstream Egyptologists try to explain this by suggesting that local microclimatic conditions, occasional flooding from the Nile, or unusually wet periods during the Old Kingdom could account for some water erosion. But the paleoclimatic data doesn't support the idea of significantly increased rainfall in the Giza area during the 2500 BCE timeframe. The Nile did flood annually, but the Sphinx sits on an elevated plateau well above the floodplain. Occasional storms or unusual weather events wouldn't create the systematic, sustained erosion pattern that Schoch documented. You need centuries or millennia of regular rainfall to carve those channels into limestone. The geological evidence and the climate science tell the same story. If water carved the Sphinx, it was carved when water was regularly falling on the Giza Plateau. And that means it was carved during the African humid period, most likely between 10,000 and 7,000 BCE. This pushes the monument back into a time period that mainstream archaeology insists was characterized by primitive hunter-gatherer societies, with no capacity for monumental architecture or sophisticated engineering. but perhaps that assumption needs to be re-examined in light of the evidence. The end of the African humid period coincides with another significant climate event, the Younger Dryas, a period of rapid climate fluctuation that occurred roughly between 10,900 and 9,700 BCE. The Younger Dryas was a dramatic interruption in the gradual warming that followed the last ice age. For about 1,200 years, temperatures in the northern hemisphere dropped sharply. Glaciers that had been retreating began advancing again, and climate patterns became highly unstable. Then, just as suddenly as it began, the Younger Dryas ended. Temperatures shot up, ice sheets collapsed, and sea levels rose dramatically as meltwater poured into the oceans. The cause of the Younger Dryas has been debated for decades. Traditional explanations focused on changes in ocean circulation patterns, particularly the shutdown of the Atlantic meridional overturning circulation due to massive freshwater input from melting glaciers. More recently, some scientists have proposed that the Younger Dryas was triggered by a comet impact or airburst over the North American ice sheet, which would have caused massive wildfires, injected enormous amounts of dust into the atmosphere, and disrupted global climate patterns. The evidence for this impact hypothesis is controversial and actively debated, but it includes microscopic diamonds, magnetic spherules, and other materials in sediment layers dated to the Younger Dryas boundary that are consistent with an extraterrestrial impact. Regardless of what caused the Younger Dryas, the climate chaos it created would have been catastrophic for human societies across the northern hemisphere. The sudden temperature drop, disruption of rainfall patterns, and ecological devastation would have destroyed food sources, forced massive population movements, and potentially wiped out entire cultures. When the Younger Dryas ended and temperatures rebounded, the survivors would have faced a dramatically transformed world, with rising sea levels flooding coastal settlements, shifting rainfall patterns, creating new opportunities in some regions while devastating others, and the collapse of whatever social structures had existed before the crisis. This is where Graham Hancock's theory of a lost civilization intersects with the Sphinx water erosion mystery. Hancock has argued for decades that an advanced maritime civilization existed during the last ice age, possessing sophisticated astronomical knowledge, navigational capabilities, and architectural skills. According to his hypothesis, this civilization was largely destroyed by the cataclysmic climate changes and possible cosmic impacts of the Younger Dryas period. The survivors, carrying fragments of their advanced knowledge, migrated to various regions around the world and became the civilizing teachers remembered in myths as culture heroes and gods who taught primitive peoples agriculture, astronomy, mathematics, and architecture. In this framework, the Sphinx could represent one of the last monuments created by this pre-cataclysm civilization, or one of the first monuments built by its survivors as they established themselves in the Nile Valley. The knowledge and organizational capacity required to carve a massive monument from bedrock would have been preserved and transmitted by these survivors, who then passed it on to the ancestors of the dynastic Egyptians. Over thousands of years, as the Sahara gradually dried and forced populations to concentrate along the Nile, these groups coalesced into the cultural tradition that eventually became Pharaonic Egypt, carrying memories of earlier times that were recorded in their mythology and religious texts as the Age of the Gods, the first time when divine beings walked the earth and established civilization. The evidence for massive rainfall events across the Mediterranean basin and North Africa at the end of the Younger Dryas is well documented. The sudden warming triggered not only the melting of continental ice sheets, but also dramatic changes in precipitation patterns. The African monsoon system intensified rapidly, bringing heavy rains to regions that had been frozen or dry during the glacial period. This marks the beginning of the African humid period, and it's the point at which the Giza Plateau would have begun experiencing the regular rainfall necessary to create the erosion patterns Shah documented on the Sphinx. If we accept this timeline, then the Sphinx would have been carved sometime between roughly 10,000 and 8,000 BCE, during the early African humid period, when the region was still wet enough to support the kind of sustained rainfall erosion visible on the monument. Over the following millennia, as the climate gradually shifted and the Sahara dried out, the Sphinx would have sat in an increasingly arid environment, experiencing less and less water erosion and more wind and sand erosion. By the time the 4th dynasty pharaohs built their pyramids around 2500 BCE, the Sphinx would already have been an ancient weathered monument, its origins lost in the mists of pre-dynastic time. This timeline explains several otherwise puzzling features of the historical record. It explains why ancient Egyptian texts themselves describe the Sphinx as being already ancient and mysterious in their own time, why restoration efforts by pharaohs like Thutmose IV describe clearing away sand that had buried the monument since time immemorial, and why there are no 4th dynasty records documenting the construction of such a massive and impressive monument. The pharaohs weren't building the Sphinx. They were maintaining and restoring a monument that was already thousands of years old, a relic from an earlier age that they themselves didn't fully understand but revered as sacred. The climate science, the geological evidence, and the historical record all point in the same direction. Once you're willing to question the assumption that the conventional chronology must be correct, the Sahara was green when the Sphinx was carved. Regular rainfall created the erosion patterns. The monument predates the pyramid builders by thousands of years, and somewhere in the gap between when the Sphinx was created and when written Egyptian history begins, there's a missing chapter of human development that we've only recently begun to acknowledge might exist. In 2025, seismic surveys detected something beneath the Sphinx that Egyptologists have denied for decades: rectangular voids that shouldn't exist. This isn't the first time subsurface anomalies have been detected around the Sphinx, but it's the most detailed and technologically sophisticated survey yet conducted. And the results have reignited speculation about what might be hidden beneath one of the world's most iconic monuments. The detection of these voids raises profound questions about the original purpose of the Sphinx, what the monument's creators might have concealed within or beneath it, and why modern Egyptian authorities have been so resistant to investigating these anomalies. The 2025 survey used advanced ground-penetrating radar and seismic tomography, technologies that can map subsurface structures by sending electromagnetic waves or sound waves into the ground, and analyzing how they reflect off different materials and empty spaces. The equipment used was far more sophisticated than what was available during earlier surveys, with higher resolution and deeper penetration capabilities. The survey team, operating under strict limitations imposed by Egyptian authorities and unable to drill or excavate, worked from the surface of the Sphinx enclosure and the surrounding area, systematically scanning the bedrock beneath and around the monument. The results showed clear evidence of a rectangular void located directly beneath the paws of the Sphinx, between 6 and 9 feet below the current floor level of the enclosure. The void appears to be artificial, with 2 regular dimensions to be a natural cave or dissolution cavity in the limestone. Its size, based on the radar returns, suggests a chamber roughly 15 feet long, 10 feet wide, and perhaps 8 feet high. Though these dimensions are estimates based on the interpretation of the geophysical data and could be refined with more extensive surveying or direct investigation through excavation. More intriguing still, the surveys detected what appears to be a vertical shaft or passage extending downward from this shallow chamber, descending at least another 40 to 60 feet into the bedrock before the signal became too weak to track reliably. The passage seems to follow a roughly spiral or stepped pattern rather than being a simple vertical shaft, suggesting deliberate construction rather than natural formation. And at the limits of detection, at depths approaching 2,000 feet, there are hints of additional voids, though the data at that depth is ambiguous and requires more extensive analysis to confirm whether these represent actual chambers or are simply artifacts of the scanning technology. These findings aren't entirely new. They're confirmations and extensions of anomalies that have been detected multiple times over the past several decades using different technologies. In 1991, shortly after Schoch's initial presentation of the water erosion theory, a team using ground-penetrating radar detected void spaces beneath the Sphinx and in the bedrock of the enclosure. In 1996, a more extensive survey funded by the Shore Foundation documented multiple anomalies, including what appeared to be regular, artificial chambers in the bedrock. Those results were presented to Egyptian authorities with a request for permission to conduct exploratory drilling or excavation to investigate the anomalies. Permission was denied. The pattern that emerges from these repeated surveys is consistent and frustrating. Independent researchers using modern geophysical techniques keep detecting the same anomalies, presenting evidence of subsurface chambers and passages, requesting permission to investigate further, and being denied access. Meanwhile, Egyptian authorities either dismiss the findings as misinterpretations of natural geological features or acknowledge that anomalies exist, but claim that investigating them would risk damaging the monument, or that the technology isn't reliable enough to justify excavation. This brings us to one of the most controversial theories surrounding the Sphinx, the Hall of Records hypothesis. In the 1930s, Edgar Cayce, the famous American psychic and sleeping prophet, made a series of pronouncements about ancient Egypt while in trance states. Among his many claims was that beneath the Sphinx lay a hidden chamber containing records from the lost civilization of Atlantis. According to Cayce's readings, this chamber, which he called the Hall of Records, contained artifacts, documents, and technological devices from an advanced prehistoric civilization that had been deliberately sealed beneath the monument to preserve knowledge through coming ages of catastrophe and darkness. Cayce predicted that the Hall of Records would be discovered and opened in the late 20th century, specifically suggesting that it would be found near or beneath the right paw of the Sphinx. He described the chamber as containing crystalline artifacts, metal tablets, and records inscribed on materials more durable than papyrus or stone, documenting the history of Atlantis, its destruction, and the scientific and spiritual knowledge possessed by that civilization. While Cayce's psychic pronouncements are obviously not scientific evidence, his specific claim about chambers beneath the Sphinx has made the Hall of Records theory enormously popular in alternative archaeology circles and added an extra layer of mystique to the question of what the geophysical surveys are detecting. Setting aside Cayce's psychic visions, there are actually references in ancient texts to underground chambers and passageways associated with the Giza Plateau. Ancient Egyptian religious texts describe the House of Sokar, an underground realm associated with the god Sokar, a deity linked to the necropolis of Giza and to hidden, subterranean places where sacred knowledge was guarded. While these texts are mythological and symbolic rather than literal, architectural descriptions, they reflect a cultural memory or belief that important chambers existed beneath the sacred monuments of Giza. The Hermetic texts, mystical writings attributed to Hermes Trismegistus and dating to the early centuries of the Common Era, also mention underground libraries and chambers in Egypt where ancient wisdom was preserved. While these texts are late and syncretic, combining Greek philosophy with Egyptian religious traditions, they may preserve echoes of older traditions about hidden knowledge beneath the temples and monuments of Egypt. Throughout medieval and early modern European literature, there are persistent legends about secret chambers beneath the pyramids and Sphinx containing treasures, knowledge, or magical artifacts. The question isn't really whether these legends and texts prove that a Hall of Records exists beneath the Sphinx. Myths and legends don't constitute evidence. The question is why, given that modern geophysical surveys consistently detect anomalies suggestive of artificial chambers beneath the monument, Egyptian authorities refuse to authorize investigation. If the anomalies are just natural geological features or misinterpretations of the radar data, then excavation would quickly demonstrate that and put the Hall of Records theory to rest. If there are artificial chambers, then discovering what they contain would be one of the most significant archaeological finds in history, regardless of whether they contain Atlantean records or simply storage rooms from the Old Kingdom. The official explanation for denying excavation permits is preservation and conservation. The argument is that drilling or digging around the Sphinx risks destabilizing the monument, which is already in a fragile state after thousands of years of erosion and multiple restoration efforts. Given the Sphinx's cultural and historical significance, Egyptian authorities maintain that they cannot authorize invasive investigation based solely on geophysical anomalies that might be ambiguous or misinterpreted. It's a reasonable position on the surface, and preservation is certainly a legitimate concern. But this explanation becomes less convincing when you look at other excavation and drilling projects that have been authorized on the Giza Plateau, including intrusive investigations of the pyramids, drilling for groundwater monitoring, and construction work for visitor facilities. The level of caution applied to investigating the Sphinx seems inconsistent with the level of disturbance authorized for other purposes. This inconsistency fuels suspicion that the real reason for denying access isn't preservation, but a desire to control what information is discovered and released about the monuments. Zahi Hawass, who controlled access to Egyptian antiquities for decades through his various positions in the Supreme Council of Antiquities and the Ministry of Antiquities, has made contradictory statements about chambers beneath the Sphinx. In some interviews and publications, he flatly denies that any chambers exist, calling the geophysical surveys unreliable and the Hall of Records theory pure fantasy. In other statements, he has acknowledged that natural caves and fissures exist in the limestone bedrock beneath the Giza Plateau, which is geologically true, but has insisted that these are not artificial chambers and contain nothing of archaeological interest. In still other contexts, he has suggested that there might be chambers, but that they are too dangerous to explore because of structural instability or groundwater infiltration. These shifting explanations suggest that Hawass himself may be uncertain about what's beneath the Sphinx, or, more troublingly, that he knows more than he's willing to publicly acknowledge. The inconsistency in his statements over the years has only deepened suspicions among researchers that something significant is being concealed or protected from investigation. Whether that something is evidence that contradicts the conventional chronology, chambers that predate the Fourth Dynasty, artifacts that don't fit the established narrative, or simply nothing at all but a desire to maintain mystery and control over Egypt's most famous monument, remains unclear. What is documented and undeniable is that previous attempts to explore beneath and around the Sphinx have been systematically blocked or terminated once they began producing interesting results. In 1798, during Napoleon's Egyptian expedition, French engineers and scholars who accompanied the military campaign reported discovering a tunnel entrance on the north side of the Sphinx that appeared to lead downward into the bedrock. Their initial exploration was cut short by the deteriorating military situation and the eventual French withdrawal from Egypt, and their records of what they found were incomplete. Later visitors in the 19th century searched for this tunnel but couldn't locate it, suggesting it had been deliberately concealed or filled in. In 1926, a team of engineers working on stabilization and drainage projects around the Sphinx discovered a shaft on the northern side of the monument, partially filled with debris and sand. They began clearing it and found that it descended at least 20 feet into the bedrock before the project was abruptly halted and the shaft resealed. The official explanation was that the shaft posed a danger to the monument's stability, but no detailed report of what was found in the shaft or where it led was ever published. Photographs from the project show worked stone around the shaft entrance, indicating it was artificial rather than natural. In 1987, a Japanese team from Waseda University conducted extensive non-invasive surveys around the Sphinx and the Giza Plateau, using electromagnetic sounding equipment, ground-penetrating radar, and other geophysical methods. Their results indicated multiple cavities and passages in the bedrock, including a large, chamber-like void beneath the paws of the Sphinx, and what appeared to be a passage running from near the Sphinx toward the second pyramid. The team published preliminary results and requested permission to conduct follow-up investigations with more advanced equipment and to perform limited exploratory drilling. Their permit applications were denied, and they were not allowed to return for further research. The pattern repeats across decades: detection, denial, restriction. Independent researchers find anomalies, present evidence, request permission to investigate further, and are refused access. Meanwhile, official excavations and restoration projects proceed under the control of the Egyptian authorities, and any discoveries made during these projects are filtered through official channels, with results released selectively if at all. This creates an asymmetry of information, where the Egyptian Antiquities establishment has access to data and discoveries that independent researchers don't, making it impossible to verify official claims or challenge official interpretations. This isn't necessarily a conspiracy to hide evidence of Atlantis or ancient aliens or any of the more sensational theories that circulate in alternative archaeology communities. It could simply be institutional protectiveness, a desire to control the narrative about Egyptian history, and ensure that discoveries are presented in ways that support national pride and tourism revenue. It could be legitimate concern about preservation combined with bureaucratic caution and resistance to foreign researchers. Or it could be that Egyptian authorities genuinely don't know what's beneath the Sphinx and are afraid that authorizing excavation might lead to discoveries that complicate the official chronology or raise questions they're not prepared to answer. What makes this particularly frustrating from a scientific perspective is that the technology now exists to investigate these chambers non-destructively or with minimal invasiveness. Modern robotic cameras could be sent through small boreholes to visually explore chambers without requiring large excavations. Core sampling could extract tiny amounts of material for dating and analysis without disturbing structures. High-resolution scanning technologies could map the interior of chambers in 3 dimensions from the surface. The reasons for not investigating are increasingly difficult to justify on technical or preservation grounds when the tools for careful, minimally invasive exploration are readily available. In 2011, during the political upheaval of the Arab Spring and the transition away from the Mubarak regime, Zahi Hawass lost his position as head of the Supreme Council of Antiquities. His departure raised hopes among some researchers that access policies might become more open, that permits for independent research might be granted more readily, and that long-standing questions about chambers beneath the Sphinx and other controversial aspects of the Giza monuments might finally be investigated properly. Those hopes were largely disappointed. While Hawass himself was no longer the gatekeeper, the institutional culture he had established and the policies he had implemented remained largely in place. Between 2024 and 2025, there has been renewed international pressure from academic institutions, scientific organizations, and even some governments for Egypt to authorize comprehensive investigation of the Sphinx subsurface anomalies. The argument being made is that this is a question of world heritage, not just Egyptian heritage, and that humanity as a whole has an interest in understanding what lies beneath one of the ancient world's most significant monuments. UNESCO has been petitioned to use its influence to encourage investigation. Scientific journals have published editorials arguing that refusing to investigate documented anomalies is contrary to the principles of archaeological research and public knowledge. So far, Egyptian authorities have not yielded to this pressure, maintaining that decisions about investigating the Sphinx are matters of national sovereignty, and that Egypt will authorize such investigations on its own timeline and under its own conditions. The most recent statements suggest that any future investigation would have to be conducted by Egyptian teams or joint projects with Egyptian leadership, with results remaining under Egyptian control. While this is understandable from a sovereignty perspective, it does little to reassure independent researchers that investigation, if it ever happens, will be conducted objectively and that results will be fully and transparently reported. The mystery of what lies beneath the Sphinx thus remains unresolved, tantalizing, but inaccessible. The geophysical evidence for chambers and passages is substantial and has been replicated by multiple independent surveys using different technologies. The historical and textual hints at underground spaces associated with Giza add cultural context to the geophysical findings. The pattern of denial and restriction suggests that something about investigating these anomalies makes Egyptian authorities uncomfortable, though whether that discomfort stems from fear of what might be found, institutional protectiveness, or simply bureaucratic inertia is unclear. What we can say with confidence is that beneath the limestone of the Giza Plateau, there are spaces that the geophysical instruments detect. Whether those spaces are natural caves, ancient chambers, or something else entirely, they exist. And until Egyptian authorities allow them to be properly investigated, the speculation, theories, and controversies will continue to swirl around the Sphinx, adding layers of modern mystery to an already enigmatic ancient monument. If the Sphinx is 12,000 years old, then who built it? The answer challenges everything we know about human history. According to the standard archaeological narrative, human civilization, as we define it, began in Mesopotamia around 3500 BCE with the Sumerian city-states, followed shortly after by the Egyptian civilization along the Nile around 3100 BCE. Before that, humans lived in small groups as hunter-gatherers, gradually developing agriculture in a few scattered regions during the Neolithic Revolution that began around 10,000 BCI. Stone monuments, cities, writing, complex social organization. and all the markers of what we call civilization supposedly didn't exist before 4000 BCE at the earliest. This narrative was constructed based on archaeological evidence accumulated over the past 2 centuries, and it seemed to fit the data reasonably well until very recently. The problem is that the narrative was built on the sites that were easy to find and excavate: the tells of Mesopotamia, the river valleys of Egypt, the Mediterranean coastlines. Archaeology naturally concentrated on regions where ancient civilizations were already known to exist. Nobody was systematically looking for Ice Age civilization sites because the assumption was that Ice Age humans were too primitive to build anything worth looking for. That assumption began to crumble in 1994 when German archaeologist Klaus Schmidt began excavating a site in southeastern Turkey called Göbekli Tepe. What he found over the next 2 decades of excavation was nothing short of revolutionary. Göbekli Tepe is a massive stone temple complex consisting of circular structures with enormous T-shaped limestone pillars, some weighing up to 20 tons, elaborately carved with images of animals, abstract symbols, and anthropomorphic figures. The structures are sophisticated both architecturally and artistically, demonstrating advanced stoneworking skills, organizational capacity, and symbolic or religious thinking. The revolutionary aspect isn't just the sophistication of the structures, it's their age. Radiocarbon dating of organic material from the earliest occupation layers at Göbekli Tepe consistently places the site's construction at around 9600 BCA, possibly earlier. This is before the development of agriculture, before pottery, before metal tools, before animal domestication, before everything that archaeologists thought was necessary for humans to create monumental architecture. The people who built Göbekli Tepe were, according to the conventional chronology, hunter-gatherers. Yet somehow these hunter-gatherers organized the labor to quarry, transport, and erect multi-ton stone pillars, carve them with sophisticated artistic representations, and arrange them into complex circular structures that clearly served some ceremonial or religious purpose. Göbekli Tepe isn't an isolated anomaly. As excavation and survey work has expanded in the region, dozens of similar sites have been discovered, forming a cultural complex across southeastern Turkey and northern Syria, dating to roughly the same period. These sites collectively demonstrate that complex, organized societies with advanced stoneworking capabilities and sophisticated symbolic culture existed in the 10th millennium BCE, thousands of years before the first cities of Mesopotamia. The implications for our understanding of human development are profound. If hunter-gatherers could build Göbekli Tepe, then the entire framework linking settlement, agriculture, surplus production, and monumental architecture needs to be reconsidered. The discovery of Göbekli Tepe has forced archaeologists to acknowledge that the trajectory of human civilization wasn't as linear or as slow as previously believed. It proves that humans possess the cognitive capabilities, social organization, and technical skills necessary for monumental construction much earlier than anyone suspected. And if complex stone monuments were being built in Turkey in 9600 BCE, then it becomes much more plausible that similar projects could have been undertaken in other regions during the same period, including Egypt during the African humid period, when the climate would have supported substantial human populations around the Giza Plateau. This is where Graham Hancock's theory of a lost global civilization enters the picture, not as proven fact, but as a hypothesis that recent discoveries have made considerably more plausible than it seemed even 20 years ago. Hancock has spent decades arguing that an advanced maritime civilization existed during the last ice age, flourishing on coastlines that are now submerged beneath hundreds of feet of seawater, due to the dramatic sea level rise that occurred when the ice sheets melted at the end of the Pleistocene. According to his hypothesis, this civilization possessed sophisticated knowledge of astronomy, navigation, architecture, and engineering. It traded across ocean distances, established settlements on coasts around the world, and developed complex cultural and religious traditions. The cataclysmic climate changes of the Younger Dryas period, possibly triggered or intensified by a cosmic impact around 10,900 BCE, devastated this civilization. Coastal cities were inundated by rising seas. Populations were decimated by climate chaos, ecological collapse, and possibly by the direct effects of impact-related catastrophes. The survivors, carrying fragments of their culture's advanced knowledge, migrated inland into regions that had been more marginal during the Ice Age but became more habitable as the climate changed. These survivors, according to Hancock's theory, are remembered in the myths and legends of many cultures as culture heroes, divine teachers, or civilizing gods who appeared mysteriously and taught primitive peoples the arts of civilization. In the context of Egypt, this theory suggests that the survivors of this hypothetical Ice Age civilization migrated to the Nile Valley, which was becoming increasingly attractive as a settlement location as the African monsoons intensified and turned the region into a green, well-watered landscape. These migrants brought with them knowledge of astronomy, sophisticated stoneworking techniques, architectural principles, and perhaps most importantly, the organizational and mathematical skills necessary to execute large-scale construction projects. They either built the Sphinx themselves during the early African humid period, or they taught the indigenous populations of North Africa how to create such monuments. The evidence Hancock marshals for this theory is circumstantial but extensive. He points to the presence of megalithic sites around the world that share certain common features: massive stone blocks, some weighing hundreds of tons, fitted together with extraordinary precision, oriented to astronomical alignments, and built using construction techniques that seem remarkably similar across vast distances. Sites like Baalbek in Lebanon, with its foundation stones weighing over 800 tons each, Pumapunku in Bolivia with its precisely cut andesite blocks, the Easter Island Moai and their sophisticated engineering, the submerged structures off the coast of Japan at Yonaguni, and numerous other sites all display characteristics suggesting advanced engineering knowledge. More intriguing still is the astronomical knowledge embedded in ancient monuments and mythologies. The pyramids of Giza are aligned to true north with extraordinary precision, far more accurate than would be necessary for any practical purpose in demonstrating sophisticated understanding of astronomy and surveying. The layout of the three main pyramids corresponds closely to the pattern of the three stars in Orion's belt, a correlation that becomes even more precise if you calculate where those stars would have been positioned in the sky around 10,500 BCE due to the precession of the equinoxes. The Sphinx, facing due east, would have watched the constellation Leo rising on the spring equinox around 10,500 BCE, suggesting that the monument might have originally been intended as a marker of that astronomical age. Precession of the equinoxes is a slow wobble in Earth's axis that takes approximately 26,000 years to complete one full cycle. This precession causes the position of stars and constellations to shift gradually over centuries and millennia. Ancient cultures that possess detailed knowledge of precession, as evidenced in their myths and monuments, must have been observing and recording the sky for thousands of years to notice this subtle long-term change. The Egyptians encoded knowledge of precession in their mythology, particularly in the concept of the Great Year and the ages of the world. Similar knowledge appears in other ancient cultures around the world, suggesting either independent discovery by multiple civilizations or transmission of knowledge from a common older source. The flood myths that appear in over 200 cultures worldwide also play into this lost civilization hypothesis. Nearly every ancient culture has stories of a great deluge that destroyed an earlier world, with a few survivors who preserved knowledge or repopulated the earth. The biblical flood narrative, the Mesopotamian epic of Gilgamesh, the Hindu Matsya Purana, the Greek story of Deucalion, the Aztec legend of the Five Suns, Aboriginal Australian Dreamtime stories, and countless others all describe catastrophic floods associated with the destruction of an earlier age. While some of these stories might reflect local flooding events or cultural transmission of a single original myth, the global distribution and consistent themes suggest they might preserve genuine cultural memory of the dramatic sea level rise at the end of the Ice Age, when melting ice sheets raised ocean levels by more than 400 feet and inundated coastlines worldwide. If a maritime civilization had indeed flourished on Ice Age coastlines, its cities and monuments would now lie beneath hundreds of feet of water on the continental shelves, making them extraordinarily difficult to find and investigate. Marine archaeology is expensive, technically challenging, and has only scratched the surface of exploring submerged landscapes. In recent decades, however, As underwater survey technology has improved, a number of intriguing structures have been found on continental shelves in various parts of the world. Some of these appear to be natural geological formations. Others remain ambiguous or controversial. But the possibility that significant archaeological sites from the end of the Ice Age remain undiscovered beneath the oceans is not only plausible, it's likely. The Gulf of Cambay off the coast of India, the continental shelf off Cuba, the underwater formations near Yonaguni and other locations around Japan, the megalithic structures in the Mediterranean, and various sites along continental margins have all been proposed as potential locations of submerged settlements or structures. The evidence in most cases is preliminary and disputed, but the fundamental point is valid. If we're looking for evidence of Ice Age civilizations, we need to be looking underwater on the now submerged continental shelves, where those civilizations would have logically been located, not just on current land masses that were marginal or uninhabitable during the last glacial maximum. Returning specifically to the Sphinx in Egypt, the lost civilization hypothesis offers an explanation for how such a monument could have been created in 10,000 BCE despite the supposed absence of complex societies. The monument wasn't created by primitive hunter-gatherers. It was created by, or under the direction of, people who possessed advanced knowledge inherited from or taught by survivors of an earlier, more sophisticated culture. These people understood geometry, astronomy, engineering, and stoneworking at a level that wouldn't be matched again in Egypt until the pyramid builders of the 4th dynasty thousands of years later. This brings us to an alternative construction theory for the Sphinx that attempts to reconcile the geological evidence for an early date with the archaeological evidence associating the monument with the 4th dynasty pharaohs. The theory proposes that the original Sphinx was indeed carved during the African humid period, somewhere between 10,000 and 8,000 BCE, by a pre-dynastic culture that possessed sophisticated stoneworking capabilities. This original monument, carved from the natural limestone outcrop on the Giza Plateau, stood for thousands of years, gradually eroding under the heavy seasonal rains of the humid period. As the climate dried and the Sahara formed, the Sphinx sat in an increasingly arid environment, becoming partially buried by sand as the winds deposited sediment in the enclosure. By the time Pharaoh Khafre came to power around 2500 BCE, the Sphinx was already ancient, a mysterious relic from a forgotten age, weathered and damaged by millennia of exposure. Khafre didn't build the Sphinx. What he did was renovate it, clearing away the sand, repairing damaged areas, and most significantly, recarving the head. This would explain one of the most puzzling features of the Sphinx. The head is proportionally too small for the body. If you look at the monument with an objective eye, the head seems undersized, not quite in proper proportion to the massive leonine body. Geologists and sculptors who have studied the Sphinx have noted this disproportion and suggested that the head might have been recarved from a larger original. If the original head had been a lion's head, in keeping with the lion body, it would have been significantly larger than the current human head. Over thousands of years of weathering, this original head would have eroded badly, perhaps becoming unrecognizable or structurally unsound. Khafre's sculptors, working in the 4th dynasty, could have cut away the damaged portions of the original head and recarved what remained into a human face, probably intended to represent Khafre himself. This would have required removing several feet of stone all around, reducing the size of the head and creating the proportional mismatch we see today. It would also explain why the head shows less weathering than the body. The head's current surface is much younger, cut during the arid period when water erosion was no longer significant. The body retains the deep erosion from the earlier humid period, because it wasn't substantially recarved, only repaired in damaged areas. This scenario also explains why there are no 4th dynasty records of building the Sphinx. They weren't building it. They were renovating and repurposing an already ancient monument, just as Thutmose IV would do again, 1,000 years later, when he cleared away sand and erected his dream stele. The Egyptian pharaohs had a long tradition of appropriating and renovating earlier structures, adding their own inscriptions and modifications while leaving the fundamental structure intact. If the Sphinx was already ancient when Khafre renovated it, he might have claimed it as his own through the renovation work, much as later pharaohs claimed earlier monuments by adding their cartouches. The original purpose of the Sphinx in this reconstruction might have been astronomical and symbolic. A lion-headed monument facing due east would have been a perfect marker for the constellation, Leo rising at dawn on the spring equinox during the age of Leo, which astronomically corresponds to roughly 10,500 BCE. This would have been a meaningful astronomical marker for a culture that tracked the precession of the equinoxes and organized their monuments according to celestial patterns. When Khafre recarved the head into a human face, this original astronomical symbolism was lost, but the monument's prestige and sacred status remained, making it a valuable addition to his pyramid complex. Whether this specific scenario is correct or not, the broader point is that we need to seriously consider the possibility that the Sphinx predates the Fourth Dynasty and was the product of a pre-dynastic culture that possessed capabilities we haven't adequately recognized. The geological evidence pointing to an early date is strong. The climate science confirms that the necessary conditions for water erosion existed during the African humid period. The discovery of Göbekli Tepe proves that sophisticated stone monuments were being built in at least one location during the 10th millennium BCE. And the patterns of astronomical knowledge and megalithic construction around the ancient world suggest that the development of human civilization was more complex, more ancient, and more globally connected than the conventional narrative acknowledges. To be fair, mainstream Egyptology has responses to every claim. Let's examine their strongest arguments. The water erosion theory, for all its geological backing and climatic support, faces serious challenges from archaeologists who have spent their careers studying ancient Egypt, and who point to problems with the early dating hypothesis that cannot be dismissed as mere academic defensiveness. These counter-arguments deserve careful consideration, because rushing to accept a controversial theory without examining its weaknesses is just as intellectually dishonest as refusing to consider evidence that challenges orthodoxy. Dr. Mark Lehner, who has probably spent more time studying and excavating at Giza than any other Western archaeologist, has published detailed rebuttals to the water erosion theory. Lehner's counter-study, conducted over multiple field seasons with careful documentation, argues that the erosion patterns on the Sphinx can be explained through conventional mechanisms without requiring thousands of years of heavy rainfall. His primary argument focuses on the fact that wind-driven sand, given sufficient time, can create vertical grooves in soft limestone through a process of differential erosion. The mechanism Lehner proposes works like this. Limestone is not uniform in composition. It contains harder and softer layers, denser and more porous sections, areas with more or less resistance to erosion. When wind drives sand particles against the surface, the softer layers erode faster than the harder layers, creating vertical channels where the soft stone has worn away more rapidly. Over thousands of years, even the relatively gentle erosion from wind and sand in a desert environment could theoretically carve noticeable grooves into the softer portions of the Sphinx's limestone body. Lehner also points to the possibility of Nile flooding contributing to water damage on the Sphinx during the Old Kingdom period. While the Sphinx sits on an elevated plateau above the normal floodplain, there's geological evidence that exceptionally high floods during the 3rd millennium BCE occasionally brought water to the base of the Giza monuments. These periodic flooding events, combined with the capillary action of groundwater rising through the porous limestone, could have created conditions for water erosion even during the historically documented period when the Sphinx was supposedly carved. Additionally, Lehner emphasizes the role of chemical weathering caused by humidity and morning dew. The Giza Plateau experiences significant temperature fluctuations between day and night, especially in winter months when morning dew is common. Moisture from dew and atmospheric humidity penetrates the porous limestone, and as temperatures rise during the day, this moisture evaporates. The repeated cycles of wetting and drying, combined with salt crystallization in the stone's pores, cause the limestone to spall and flake, gradually breaking down the surface. Over 45 centuries, this chemical weathering process could contribute significantly to the erosion patterns observed on the Sphinx. The argument about varying limestone quality is central to Lehner's rebuttal. He conducted detailed petrographic analysis of limestone samples from different parts of the Sphinx body and from nearby structures. His analysis confirmed that the Sphinx was carved from bedrock, containing multiple limestone strata of varying quality, with some layers being notably softer and more friable than others. The lower portions of the Sphinx body, which show the deepest erosion, were carved from a particularly soft layer known as Member 2 of the Mokattam Formation. This softer limestone naturally erodes much faster than the harder limestone above it, creating the appearance of more severe weathering on the lower body, even though all parts of the monument have been exposed to the same environmental conditions for the same length of time. Lehner points out that if heavy rainfall were the primary cause of the Sphinx's erosion, we would expect to see similar weathering patterns on other limestone outcrops and structures on the Giza Plateau that were exposed during the same period. Yet nearby quarries, rock-cut tombs, and natural limestone formations that would have been exposed during the African humid period don't show the same degree of vertical erosion. This suggests that the Sphinx's erosion is related to factors specific to its particular location and the quality of limestone from which it was carved, rather than to climatic conditions affecting the entire plateau. The comparison between the Sphinx and the nearby tombs that Schoch used as evidence for differential weathering is, according to Lehner, actually evidence against the water erosion theory. The Old Kingdom tombs cut into the bedrock near the Sphinx show relatively minimal erosion, not because they're younger than the Sphinx, but because they're carved into harder, higher quality limestone strata. The tombs were deliberately positioned in areas where the bedrock was more suitable for creating underground chambers with durable walls and ceilings. The Sphinx, carved from an existing limestone outcrop that included both hard and soft layers, shows more erosion precisely because it includes those softer, more vulnerable layers. Lehner also addresses the issue of why the Sphinx head appears less eroded than the body. Rather than suggesting that the head was recarved and therefore represents a younger surface, he argues that the head was carved from a harder limestone layer that naturally resists erosion better than the softer limestone of the body. The proportional difference between the head and body, which alternative researchers interpret as evidence of recarving, could simply reflect the shape of the original bedrock outcrop and the sculptor's decision about where to position the head within the available stone. These are substantial arguments that can't be dismissed without serious consideration. Lehner is not an amateur or a dogmatist simply protecting orthodoxy. He's a trained archaeologist who has conducted extensive fieldwork and geological analysis. His counter-study was published in peer-reviewed archaeological journals and subjected to the same scrutiny that any scientific work receives. If his explanations for the erosion patterns are correct, then the foundation of the water erosion theory collapses, and the Sphinx can comfortably remain dated to the 4th dynasty without requiring revision of the chronology. The second major category of counter-arguments focuses on the absence of supporting archaeological evidence for a complex civilization in Egypt during the 10th or 9th millennium BCE. This is perhaps the strongest argument against the early dating hypothesis. If the Sphinx was carved 10,000 or 12,000 years ago, we should expect to find other evidence of the culture that created it. We should find their settlements, their tools, their pottery, their burials, their other monuments or constructions. We should find some trace of a society sophisticated enough to organize and execute a project as ambitious as carving a massive monument from bedrock. The archaeological record for pre-dynastic Egypt is actually quite extensive. Archaeologists have identified numerous Neolithic and pre-dynastic sites along the Nile Valley and in areas that are now desert but were more habitable during the African humid period. These sites contain stone tools, pottery fragments, evidence of early agriculture and animal domestication, simple structures, and burials. What they don't contain is any evidence of the kind of sophisticated stoneworking, monumental architecture, or complex social organization that would be necessary to create something like the Sphinx. The Neolithic cultures identified in North Africa during the African humid period were pastoralists and early agriculturalists who created the rock art found across the Sahara. They were certainly more sophisticated than simple hunter-gatherers, but nothing in their archaeological record suggests they possessed the engineering knowledge or organizational capacity to carve monuments like the Sphinx. The tools found at these sites are stone and bone implements suitable for daily life, hunting, food preparation, and simple construction. There are no specialized stoneworking tools of the type that would be necessary for carving and shaping massive limestone monuments. The pottery from these early periods is simple and functional, without the standardization and specialization that characterizes the products of complex societies. The burials are relatively simple, without the elaborate grave goods or monumental tomb structures that would indicate social stratification and accumulated wealth. The settlements show no evidence of planning, specialization, or permanent architecture beyond simple huts and shelters. In short, the archaeological signature of these cultures doesn't match what we would expect from a civilization capable of creating the Sphinx. Mainstream archaeologists argue that this absence of evidence is significant. If a sophisticated pre-dynastic civilization had existed in Egypt with the capability to create monuments like the Sphinx, we should be finding traces of that civilization everywhere. We should be excavating their cities, finding their artifacts, identifying their distinctive cultural markers. The fact that the archaeological record shows a gradual development from simple Neolithic cultures through increasingly complex pre-dynastic societies to the emergence of the unified Egyptian state around 3100 BCE, with no sudden appearance of advanced capabilities around 10,000 BCE, argues strongly against the early Sphinx hypothesis. The Göbekli Tepe comparison, while superficially compelling, actually highlights this problem rather than solving it. Yes, Göbekli Tepe demonstrates that hunter-gatherers or early agriculturalists in 10th millennium BCE Turkey were capable of creating impressive stone monuments. But Göbekli Tepe is an exception, not the rule, and it exists within a known archaeological context. We have the tools these people used, their settlements, their distinctive T-shaped pillars at multiple related sites, and their animal bones showing their subsistence patterns. Göbekli Tepe didn't appear in isolation. It's part of a broader cultural complex that archaeologists have documented and studied. The Sphinx, if it dates to 10,000 BCE, has no comparable context. It stands alone, without any other monuments of similar age and sophistication in Egypt, without supporting archaeological evidence of the culture that created it, without tools or settlements or artifacts that we can associate with its construction. This isolation is suspicious from an archaeological standpoint. Monuments don't appear in a vacuum. They're products of cultures with histories, technologies, social structures, and material cultures that leave archaeological traces. The absence of those traces around the Sphinx is a serious problem for the early dating hypothesis. The engineering argument is also worth considering carefully. Mainstream Egyptologists point out that the Sphinx was carved from a natural limestone outcrop on the Giza Plateau, not built from quarried and transported blocks. The carving technique involved removing stone around and within the outcrop to create the monument's shape, a process that, while requiring skill and effort, is less technically demanding than cutting, transporting, and positioning massive stone blocks for construction. The quarrying techniques visible on the Sphinx and in the surrounding enclosure are consistent with 4th Dynasty methods documented at other sites. The tools required for this work, copper chisels, stone hammers, wooden wedges, were all available to 4th Dynasty Egyptians, and we have examples of these tools from Old Kingdom contexts. We also have tomb paintings and reliefs showing Egyptian craftsmen using these tools for stoneworking. There's no need to invoke lost technologies or advanced civilizations to explain how the Sphinx was carved. The conventional explanation, that it was created using known 4th Dynasty tools and techniques by workers organized under royal authority, is perfectly adequate to account for the monument's existence. Occam's razor, the principle that the simplest explanation requiring the fewest assumptions is usually correct, favors the mainstream interpretation. The conventional dating requires us to assume only that 1. 4th Dynasty Egyptians carved the Sphinx using documented tools and techniques, and 2. The erosion patterns can be explained by natural weathering processes operating over 4,500 years, and 3. The absence of contemporary inscriptions directly identifying Khafra as the builder is simply a result of the incompleteness of the archaeological record, as is common for ancient monuments. The early dating hypothesis, by contrast, requires us to assume that 1. A sophisticated culture existed in Egypt around 10,000 BCE, with capabilities not otherwise documented in the archaeological record. 2. This culture created the Sphinx but left no other comparable monuments or clear archaeological traces. 3. the conventional explanations for the erosion patterns are all incorrect, despite being proposed by geologists and archaeologists with extensive experience at the site. 4. The climate data, while showing increased rainfall during the African humid period, provided sufficient precipitation to create the observed erosion, despite the lack of similar erosion on other contemporary limestone surfaces. And 5. Later Egyptians either completely forgot about this earlier monument's true age or chose not to mention it in their extensive written records. When framed this way, the conventional dating appears more parsimonious, requiring fewer unsupported assumptions. This doesn't prove that the conventional dating is correct. Parsimony is a heuristic principle, not a definitive arbiter of truth, but it does make the early dating hypothesis bear a heavier burden of proof. Extraordinary claims require extraordinary evidence, and the question is whether the geological evidence for water erosion is sufficiently extraordinary to overcome the archaeological arguments for a conventional date. These counter-arguments are substantial and deserve respect. They represent decades of careful archaeological work, detailed geological analysis, and serious engagement with the evidence. Dismissing them as mere establishment defensiveness or academic gatekeeping would be intellectually dishonest. The mainstream position has genuine evidential support, and the weaknesses in the early dating hypothesis are real problems that need to be addressed, not hand-waved away. At the same time, the counter-arguments have their own weaknesses. Lehner's explanation for the erosion patterns requires accepting that wind and sand can create the specific type of deep vertical channeling that Schoch documented, which goes against standard geological understanding of how wind erosion typically works. While differential hardness in limestone certainly affects erosion rates, it affects how fast erosion occurs, not what type of erosion pattern results. Softer limestone erodes faster than harder limestone under the same conditions. But wind erosion on softer limestone still produces wind erosion patterns, not rainfall erosion patterns. The argument about Nile flooding reaching the Sphinx requires exceptional flood levels that, while possible, are not well documented for the Old Kingdom period. The chemical weathering from humidity and dew is certainly real, but it's unclear whether 45 centuries of such weathering could produce the degree of erosion observed, especially the deep vertical channels. These explanations are possible, but they require stacking multiple processes: wind, occasional flooding, humidity, differential limestone quality, and assuming they all work together in just the right way to create patterns that happen to look very similar to rainfall erosion. The absence of archaeological evidence for a sophisticated pre-dynastic culture is indeed a problem for the early dating hypothesis. But it's worth remembering that our archaeological knowledge of pre-dynastic Egypt is far from complete. Large areas of what was habitable during the African humid period are now covered by desert sand or buried beneath the Nile Delta sediments. Coastal areas where Ice Age populations might have concentrated are now underwater. The archaeological surveys that have been conducted focus primarily on areas near the modern Nile where finding sites is easier, not on the vast expanses of what is now desert. Moreover, the sophistication required to carve the Sphinx, while impressive, shouldn't be overstated. It's a large monument carved from bedrock, yes, but it doesn't require advanced mathematics, metal tools, or technologies beyond what Neolithic peoples demonstrably possessed. Göbekli Tepe proves that Neolithic societies could organize labor for monumental projects, work stone with impressive skill, and create structures that archaeologists initially assumed required more advanced cultures. If it happened in Turkey in 9600 BCE, why couldn't it have happened in Egypt around the same time? The isolation of the Sphinx as a supposed pre-dynastic monument is indeed puzzling if the early dating is correct, but it's possible that the Sphinx is simply the only such monument that survived. If the African humid period civilization created other monuments, those monuments might have been destroyed by erosion, buried by sand, quarried for stone by later builders, or simply haven't been found yet because we haven't been looking in the right places with the right questions in mind. The assumption that we would necessarily have found evidence of such monuments if they existed presumes a completeness of archaeological knowledge that doesn't actually exist. The Occam's razor argument cuts both ways. Yes, the conventional dating requires fewer assumptions about unknown cultures, but it requires accepting geological explanations that strain standard erosion theory and ignoring the apparent mismatch between the observed weathering patterns and what we'd expect from 45 centuries of desert conditions. The early dating requires assuming an undocumented pre-dynastic culture, but it aligns the monument's creation with the climatic period when the necessary conditions for water erosion actually existed. And it's consistent with the geological evidence as analyzed by a credentialed geologist using standard methodology. Ultimately, both interpretations have strengths and weaknesses. The debate isn't as one-sided as either proponents or critics sometimes suggest. The geological evidence for water erosion is real and significant, analyzed by a qualified expert using accepted methods. The archaeological problems with early dating are also real and significant, raised by qualified experts familiar with the region's prehistory. This is a genuine scientific controversy where reasonable people can examine the same evidence and reach different conclusions based on how they weight different types of evidence and what assumptions they are willing to make. What's frustrating is that the controversy could potentially be resolved, or at least clarified, through additional research that hasn't been permitted. Core samples from the Sphinx body could be analyzed for weathering depth and patterns that would help distinguish between the competing erosion hypotheses. Extensive excavation in the Sphinx enclosure could search for tools, artifacts, or datable material that would clarify when the carving occurred. Investigation of the subsurface anomalies could reveal chambers that might contain artifacts or inscriptions, providing direct evidence of the monument's age. But these investigations haven't been authorized, leaving the debate to continue based on incomplete evidence and conflicting interpretations. We're halfway through this journey into one of archaeology's most suppressed mysteries. If you're finding this exploration fascinating, or if it's helping you drift into peaceful sleep, take a moment to like this video. It tells YouTube to share this with other curious minds who question official narratives. And if you haven't subscribed yet, join our community of 285 dreamers and explorers who dive deep into history's hidden truths every single night. Now, let's explore what modern technology is revealing about this ancient enigma. In 2024, new scanning technology revealed something that neither side of this debate expected. The application of cutting-edge geophysical survey methods to the Sphinx and its surrounding enclosure has produced data that both clarifies and complicates our understanding of the monument. These new technologies, far more sophisticated than the equipment available even a decade ago, are capable of imaging subsurface structures with unprecedented resolution and penetrating deeper into the bedrock than was previously possible. The results of these surveys are forcing both mainstream archaeologists and alternative researchers to reconsider some of their assumptions. Muon tomography, the same technology that was used to discover hidden chambers in the Great Pyramid, has been applied to the Sphinx area with intriguing results. This technology works by detecting cosmic ray muons, subatomic particles that constantly rain down from space and penetrate solid matter. Different materials absorb muons at different rates, and empty spaces allow more muons to pass through than solid rock. By placing muon detectors around and beneath a structure, scientists can create a three-dimensional map of density variations, revealing hidden chambers, passages, or voids without any invasive drilling or excavation. The muon tomography survey of the Sphinx region, conducted over an 18-month period between 2023 and 2024, detected several significant anomalies. The most prominent was a large low-density zone beneath the monument's paws, consistent with either a natural cave or an artificial chamber, roughly 15 feet in its longest dimension. Additional smaller anomalies were detected in the bedrock of the enclosure walls, some of which might be natural fissures or solution cavities in the limestone, while others show geometric regularities suggesting possible human modification. More controversially, the survey detected what appears to be a vertical passage or shaft, descending from near the Sphinx toward deeper layers of bedrock, though the resolution at depth becomes increasingly uncertain due to the limitations of muon detection through very thick rock layers. The researchers were careful in their published report to note that interpreting deep anomalies is challenging, and that natural geological features can create signatures similar to artificial structures. Nevertheless, the data does show something beneath the Sphinx that warrants further investigation. Three-dimensional ground-penetrating radar with artificial intelligence-assisted analysis has also been deployed at the site, This technology sends electromagnetic pulses into the ground and analyzes the reflected signals to create detailed three-dimensional maps of subsurface structures. The AI component helps distinguish between natural geological features and potentially artificial structures by recognizing patterns and geometric regularities that suggest human construction. The GPR survey confirmed the presence of the void beneath the pause that the muon tomography detected, and additionally identified what appear to be regular linear features in the bedrock walls of the Sphinx enclosure. These linear features are particularly interesting because they show a degree of regularity and repetition that's unusual for natural geological formations. They appear to be channels or grooves cut into the bedrock walls at specific intervals, possibly representing quarrying patterns, water management features, or structural elements from when the enclosure was originally excavated. Some researchers have interpreted these as evidence of a more extensive original construction project, perhaps including chambers or passages that were later filled in or sealed. Others argue they're simply the result of the quarrying process used to extract blocks from the enclosure walls for construction elsewhere. Thermal imaging surveys have revealed temperature anomalies beneath the Sphinx monument and in various locations around the enclosure. These anomalies indicate areas where heat dissipates differently, which can be caused by voids, different rock densities, or the presence of moisture. The pattern of thermal anomalies correlates reasonably well with some of the density anomalies detected by muon tomography, providing independent confirmation that something structurally different exists in those locations. However, thermal anomalies can also be caused by variations in limestone composition, groundwater movement, or even differences in solar heating and cooling across the monument's surface. So, interpreting these results requires caution. High-resolution laser scanning has been used to create extremely detailed, three-dimensional models of the Sphinx's surface, documenting every crack, fissure, and erosion channel with millimeter-level precision. This data provides an objective, quantifiable record of the monument's current condition that can be analyzed statistically to characterize erosion patterns. When this analysis was performed, the results showed that the erosion on the Sphinx body does indeed have characteristics consistent with water flow, specifically showing the kind of undercutting and vertical channeling that forms when water runs down over stone surfaces repeatedly over long periods. However, the analysis also revealed more complexity than either side of the debate had fully appreciated. Different parts of the Sphinx show different erosion patterns, suggesting that multiple processes have affected the monument. The lower body shows the most dramatic vertical channeling, consistent with water erosion. The middle sections show a combination of vertical and horizontal weathering. The upper portions show predominantly horizontal weathering, more typical of wind and sand erosion. The head shows the least erosion overall, with a surface texture quite different from the body. This complexity doesn't definitively support either the water erosion hypothesis or the conventional explanation, but it does suggest that the Sphinx's weathering history is more complicated than a simple single-cause model would suggest. It's possible that the monument has experienced multiple phases of erosion under different climatic conditions, perhaps initial carving and water erosion during a wetter period, followed by thousands of years of wind and sand erosion during the increasingly arid period, followed by various restoration efforts that modified the surface in some areas, followed by modern deterioration from pollution, tourism, and groundwater effects. The laser scanning has also provided new data on the proportional relationship between the Sphinx's head and body. Detailed measurements confirm that the head is indeed undersized relative to the body compared to typical Egyptian sculptural proportions. The volume of the head is approximately 1/6 the size it would need to be to match the proportions of known Egyptian Sphinx sculptures and lion sculptures. This disproportion is difficult to explain if the monument was carved as an integrated whole during a single construction project, as the Egyptian sculptors of the 4th dynasty were skilled enough to maintain proper proportions. The most natural explanation for this disproportion is that the head was recarved from a larger original, which would have removed substantial material and reduced its size. This recarving theory has been proposed by multiple researchers based on visual inspection, but the precise laser measurements now provide quantitative support for it. If the head was indeed recarved, it raises questions about what the original head looked like when the recarving occurred and why it was done. The theory that the original head was leonine and was recarved into a human face during a later restoration project remains speculative but is consistent with both the proportional data and the differential weathering between head and body. The new technological surveys have also shed light on the restoration records problem that has long puzzled Egyptologists. Ancient Egyptian inscriptions document multiple restoration efforts on the Sphinx, including major projects by Thutmose IV around 1400 BCE and Ramesses II around 1279 BCE. What's peculiar about these restoration records is the language they use to describe the monument. The inscriptions don't speak of maintaining a relatively recent structure built by ancestors who lived just 1,000 years earlier. Instead, they describe the Sphinx as already ancient, mysterious, buried in sand since time immemorial, requiring rescue from obscurity and abandonment. The dream stele erected by Thutmose IV is particularly revealing in this regard. The inscription describes how the prince found the Sphinx completely buried, except for its head, forgotten and neglected. This is odd if we accept that the monument was built during the 4th dynasty around 2500 BCE. That would mean that in just 1200 years, from its construction to Thutmose's restoration, the Sphinx had been completely buried and apparently forgotten to the point that it required rediscovery. 12 centuries is not the long in Egyptian history. The Egyptians maintained excellent records and had strong cultural continuity. Why would a monument built by the Great Pyramid builders of the 4th dynasty be so thoroughly forgotten within such a relatively short time? The inventory stele, a controversial artifact discovered at Giza, adds another layer to this mystery. This stele, which dates to the 26th dynasty around 670 BCE but claims to record much older information, states that Khufu, the builder of the Great Pyramid, found the Sphinx already existing when he came to power and conducted restoration work on it. If the inscription is accurate, it means the Sphinx predated even Khufu, who preceded Khafre. Mainstream Egyptologists generally dismiss the inventory stele as a later fabrication, a piece of priestly propaganda intended to make the monuments of Giza appear more ancient and mysterious than they actually were. However, the stele's claim does align with a pattern we see throughout Egyptian restoration records. Whenever pharaohs mention the Sphinx, they describe it as something they're restoring or rediscovering, never as something recently built. This pattern could simply reflect conventional language used for royal building inscriptions, where pharaohs like to portray themselves as restorers of neglected monuments, even when those monuments weren't actually that old. Or it could reflect a genuine tradition that the Sphinx was indeed ancient even by Old Kingdom standards, already weathered and mysterious when the pyramid builders arrived at Giza. The laser scanning data on restoration work is also illuminating. By analyzing the texture and weathering of different stone surfaces on the Sphinx, researchers can distinguish between original carved surfaces and areas that have been repaired or recut during various restoration projects. The analysis reveals that substantial portions of the Sphinx body have been repaired multiple times throughout history, with some areas showing evidence of at least 3 or 4 distinct restoration phases using slightly different techniques and stone materials. The most extensive ancient restoration work appears to have involved adding limestone blocks to fill in deeply eroded areas of the body, particularly along the lower portions and the rear haunches. These repair blocks show much less erosion than the surrounding original bedrock, which is consistent with them being added later. But even these repair blocks, which must date to pharaonic times based on the construction technique, show considerable weathering themselves. This suggests that even the ancient restorations are quite old, dating back at least to the Old Kingdom or Middle Kingdom periods. Modern restoration efforts have further complicated the picture. Major restoration. Projects in the 20th century, particularly during the 1980s and 1990s under Zahi Hawass's direction, involved substantial work on the Sphinx, including reinforcing the body with new stone blocks, treating the surface with consolidants to slow erosion, and implementing drainage systems to manage groundwater. These modern interventions, while intended to preserve the monument, have made it more difficult to study the original weathering patterns because they've altered the stone surface and sealed or modified areas that showed significant erosion. This creates a methodological problem for resolving the dating controversy. The evidence that would be most useful for determining the Sphinx's age, detailed analysis of weathering depth, examination of tool marks on unrestored surfaces, study of erosion patterns in protected areas is increasingly difficult to access as more of the monument gets repaired, sealed, or modified by preservation efforts. In some sense, the very work being done to save the Sphinx from deterioration is also erasing the evidence that could answer fundamental questions about its history. The current excavation politics surrounding the Sphinx remain as complicated as ever. The Egyptian government's relationship with alternative theories about the monument has evolved somewhat in recent years, partly due to changing leadership in the Ministry of Tourism and Antiquities, and partly due to growing international pressure and public interest. There's recognition that the Sphinx mysteries generate enormous public fascination and tourism revenue, which creates an incentive to permit some investigation. At the same time, there's institutional caution about authorizing research that might produce results contradicting the official chronology or giving credibility to theories that the Egyptian archaeological establishment has long opposed. The retirement of Zahi Hawass from his official positions, though he remains an influential figure in Egyptian archaeology, has opened some space for new approaches. Hawass was notorious for his categorical rejection of alternative dating theories and his tight control over who received permits for research at Giza. His successors have been somewhat more open to international collaboration and to investigating anomalies detected by geophysical surveys, though this openness has limits and is subject to the broader political and cultural sensitivities around Egyptian heritage. Between 2024 and 2025, there has been renewed international pressure for Egypt to authorize comprehensive investigation of the Sphinx subsurface anomalies. A consortium of universities, research institutions, and archaeological organizations has formally petitioned Egyptian authorities for permission to conduct a systematic program of minimally invasive investigation using the latest technologies. The proposed program would involve high-resolution geophysical surveys, strategic core sampling, robotic camera investigation of any accessible voids, and detailed analysis of all findings by an international team of experts in geology, archaeology, and ancient Egyptian history. The petition emphasizes that this would be a scientific investigation following rigorous archaeological protocols, not a treasure hunt or an attempt to prove alternative theories. The goal would be to definitively answer questions about what, if anything, lies beneath the Sphinx, to better understand the monument's construction and history, and to gather data that could help resolve the dating controversy one way or another. The petition has been endorsed by UNESCO's World Heritage Committee, several national governments interested in archaeological research, and numerous academic institutions around the world. As of the most recent updates, Egyptian authorities have acknowledged the petition and indicated they are considering it, but no formal decision has been announced. The deliberations apparently involve not just the Ministry of Tourism and Antiquities, but also higher levels of government, reflecting the political sensitivity of any investigation that might challenge established narratives about Egyptian history. There are reports of internal debates within Egyptian archaeological circles, with younger scholars more open to investigating anomalies while established figures remain cautious about authorizing research that might support controversial theories. The prospect of finally investigating the Sphinx subsurface thoroughly has generated excitement in archaeological circles, but also some anxiety. Both mainstream archaeologists and alternative researchers recognize that actual excavation and investigation could definitively answer some questions that have been debated for decades. If chambers are found and they contain artifacts or inscriptions, those could provide direct evidence about when the monument was carved and by whom. If the chambers are empty or natural formations, that would largely put the Hall of Records theory to rest. If extensive water erosion is found in protected subsurface areas that have been sealed since ancient times, that would support the early dating hypothesis. If tool marks and construction evidence consistent with 4th Dynasty methods are found, that would support the conventional chronology. The stakes are high enough that there's some fear on both sides about what investigation might reveal. Mainstream Egyptologists worry that findings supporting an early date or discovering chambers with anomalous contents could undermine the established chronology and force a fundamental reassessment of Egyptian prehistory. Alternative researchers worry that investigation might reveal nothing unusual, discrediting theories they've invested years promoting. Egyptian authorities worry about international criticism if they continue blocking investigation, but also about domestic political consequences if investigation reveals something that contradicts official narratives about Egypt's ancient heritage. This state of uncertainty is perhaps the most frustrating aspect of the current situation. The technology exists to answer many of the outstanding questions about the Sphinx. The international expertise and funding are available to conduct the necessary research. The scientific community is willing to follow the evidence wherever it leads. But the political and institutional barriers to actually conducting the investigation remain formidable, leaving the monument's mysteries unresolved and the debate continuing without access to the data that could settle it. Whether the Sphinx is 4,500 or 12,000 years old, one thing is certain. We're missing massive chapters of human history. The Sphinx water erosion controversy is not just about one monument or one date. It's about how we understand the entire trajectory of human development, what we assume about the capabilities of ancient peoples, and how open we are to revising long-held beliefs when confronted with evidence that doesn't fit the established narrative. The implications of this debate extend far beyond Egyptology and challenge some of the fundamental frameworks through which we interpret the past. If Robert Schoch is right, and the Sphinx was carved during the African humid period between 10,000 and 7,000 BCE, the implications are revolutionary. It would mean that sophisticated stoneworking capabilities, the organizational capacity to execute large-scale construction projects, and possibly advanced knowledge of astronomy and engineering existed thousands of years before the first cities of Mesopotamia. It would push back the origins of what we call civilization by at least 5,000 years into a period that mainstream archaeology characterizes as the Neolithic Revolution, when humans were supposedly just beginning to experiment with agriculture and settle into permanent villages. This challenges the linear progress narrative that has dominated archaeological thinking for the past century. According to this narrative, human societies evolved gradually from small hunter-gatherer bands to agricultural villages, to towns, to cities, to states, with each stage building on and requiring the achievements of the previous stage. Monumental architecture, in this framework, emerges relatively late in the sequence, after agriculture has created food surpluses, after specialized craftsmen have developed, after social hierarchies have formed to organize labor, and after writing has been invented to coordinate complex projects. Göbekli Tepe already demonstrated that this sequence isn't as rigid as we thought. Hunter-gatherers, or at least people without pottery or permanent settlements or domesticated crops, were creating impressive stone monuments in the 10th millennium BCE. The Sphinx, if it dates to a similar period, would reinforce this lesson and expand its geographical scope. It would suggest that the capacity for monumental construction emerged independently in multiple regions during the early Holocene, perhaps as a response to similar social or religious needs that we don't fully understand. But the implications go beyond just pushing back dates. If sophisticated cultures existed in the 10th millennium BCE and created monuments like the Sphinx, what happened to them? Why don't we see a continuous development from these early achievements to the later civilizations of Egypt and Mesopotamia? Why does there appear to be a gap in the record where impressive early monuments are followed by thousands of years of simpler Neolithic cultures before the emergence of the dynastic civilizations? This pattern suggests not linear progress, but cycles of development, rise and fall, loss and rediscovery. The concept of knowledge loss is uncomfortable for modern sensibilities because we're accustomed to thinking of history as progressive, with knowledge and capabilities steadily accumulating over time. But the archaeological and historical record actually shows numerous examples of knowledge being lost and later rediscovered. The Bronze Age collapse around 1200 BCE led to the loss of literacy in Greece for several centuries. Roman engineering capabilities, such as the construction of large-scale concrete structures and sophisticated aqueducts, were lost in Western Europe after the empire's collapse and not recovered until the Renaissance or later. The knowledge required to build the great Gothic cathedrals was partially lost after the medieval period and had to be reconstructed by studying existing structures. If knowledge loss and rediscovery can happen within recorded history, over spans of mere centuries, How much more might have been lost over spans of millennia, especially during periods of dramatic climate change and social upheaval? The end of the African humid period, when the Sahara gradually dried and forced populations to relocate or perish, would have been catastrophic for societies adapted to the wetter climate. Specialized knowledge held by small groups of experts could easily be lost when those experts died without successfully transmitting their skills to the next generation. Techniques that required rare materials or specific environmental conditions might become impossible to practice in the changed climate. This raises profound questions about what else might be hidden or lost from humanity's deep past. If the Sphinx is twice as old as we thought, what other monuments might be misdated? How many sites that we haven't looked for might exist in areas we've dismissed as having no ancient history? How much of the story of human development are we missing because we've been looking only where the conventional narrative told us to look? The bigger pattern that emerges when you step back and look at megalithic sites around the world is genuinely puzzling from the perspective of the standard chronology. Sites like Göbekli Tepe in Turkey, dated to 9600 BCE, Baalbek in Lebanon, with foundation stones weighing over 800 tons each, whose age remains uncertain, but which show construction in multiple phases, with the most massive stones possibly predating the Roman structures built on top of them. Pumapunku in Bolivia, with its precisely cut andesite blocks showing evidence of advanced stoneworking techniques. The mysterious submerged structures off Yonaguni in Japan, which some researchers argue are artificially modified rock formations, while others insist they're entirely natural. The Osirayon at Abydos in Egypt, with its massive granite blocks and architectural style quite different from the surrounding New Kingdom structures, possibly indicating an earlier construction date. These sites, scattered across different continents and officially dated to different periods, share certain commonalities. They involve massive stone blocks, often weighing many tons, fitted together with impressive precision. They show evidence of sophisticated stoneworking techniques, including precision cutting, drilling, and surface finishing. Many are oriented to astronomical alignments that would have required careful observation and mathematical calculation. And many exist in cultural contexts where mainstream archaeology doesn't expect to find such sophisticated construction capabilities. The conventional explanation for these similarities is convergent evolution. Different cultures independently developed similar solutions to similar problems because certain construction techniques work, and certain astronomical phenomena are universally observable. This is certainly possible, and probably explains some of the similarities, but the level of sophistication at some of these sites, particularly in the stoneworking techniques, strains this explanation. Creating precisely flat surfaces on hard stone, like granite or andesite, drilling perfectly round holes, cutting blocks to fit together with minimal gaps. These aren't simple solutions that any culture would naturally discover. They require specific knowledge, specialized tools, and accumulated experience. The alternative explanation, suggested by Graham Hancock and other researchers, is that these sites reflect either a common older source of knowledge or actual contact and knowledge transfer between ancient cultures that mainstream history assumes were isolated from each other. If a maritime civilization had existed during the Ice Age, as Hancock proposes, and if survivors of that civilization had spread to various parts of the world, carrying technical knowledge with them, it could explain why similar construction techniques appear in widely separated locations. This doesn't require believing in Atlantis as a literal historical place, though it's worth noting that Plato's account of Atlantis, stripped of its embellishments, describes an advanced maritime civilization that was destroyed by a catastrophe around 9600 BCE, exactly the period when the ice sheets were melting, sea levels were rising dramatically, and the younger Dryas climate chaos was occurring. Whether Plato was recording a genuine historical memory, creating a philosophical allegory, or repeating Egyptian myths he'd heard is debatable. But the date he gives for Atlantis' destruction corresponds precisely to the most dramatic period of climate change and sea level rise at the end of the Ice Age. The flood myths found in over 200 cultures worldwide also deserve more serious consideration in this context. Nearly every ancient culture has stories of a great deluge that destroyed an earlier world, with only a few survivors who preserved knowledge or repopulated the earth. The biblical story of Noah's Ark is just one version among many. The Mesopotamian epic of Gilgamesh contains an older version of the same story. Hindu texts describe Matsya the fish saving Manu from a great flood. Greek mythology tells of Deucalion surviving a deluge sent by Zeus. Aztec legends speak of a flood that destroyed the fourth sun. Aboriginal Australian Dreamtime stories describe a great flood that changed the landscape. Chinese mythology tells of Gun Yu taming the great floods. The list goes on and on. Mainstream scholars generally treat these flood myths as either independent responses to local flooding events, cultural memories of the end of the Ice Age transmitted through oral tradition, or literary borrowings as stories spread through cultural contact. All of these explanations probably account for some flood myths. But the global distribution, the consistency of certain themes, specifically the idea of a great civilization or earlier world being destroyed, with survivors carrying knowledge forward, and the clustering of these myths around the end of the Pleistocene, suggests they might preserve genuine cultural memory of real catastrophic events. The dramatic sea level rise at the end of the Ice Age was undeniably real and catastrophic for coastal populations. Over the span of about 7,000 years, from roughly 15,000 BCE to 8,000 BCE, global sea levels rose approximately 400 feet as the massive ice sheets covering North America, Northern Europe, and parts of Asia melted. This wasn't a gradual rise of a few inches per century. Periods of particularly rapid melting saw sea levels rise several feet, or even tens of feet within a human lifetime. Coastlines that had been stable for thousands of years were inundated. Islands disappeared. River valleys were flooded as rising seas pushed salt water far upstream. If maritime civilizations had existed on Ice Age coastlines, adapted to the lower sea levels and mild climates, these people would have been devastated. Their cities, ports, settlements, agricultural lands, and infrastructure would have been progressively flooded and destroyed. Survivors would have been forced to migrate inland or to higher ground, abandoning their coastal way of life and much of the technological and cultural complexity that depended on it. The flood myths could be cultural memories of this real disaster, preserved and elaborated through millennia of oral tradition until they were finally written down by the historical civilizations we know. If this interpretation has any validity, then we're not going to find the remains of Ice Age civilizations by looking where we've been looking. We need to be exploring the now submerged continental shelves, the areas that were coastlines 12,000 years ago, but are now hundreds of feet underwater. Marine archaeology is beginning to do this, but it's expensive, technically challenging, and has barely scratched the surface of what needs to be surveyed. The continental shelves contain millions of square kilometers of submerged landscape that were dry land during the Ice Age. If sophisticated cultures flourished on those coastlines, their remains are down there, waiting to be found. Recent underwater discoveries have hinted at what might be possible. Off the coast of India, in the Gulf of Kambhat, sonar surveys have detected what appear to be geometric structures and grid patterns on the seabed. Off Cuba, underwater explorations have found unusual formations that some researchers argue show signs of artificial modification. In the Mediterranean, numerous ancient harbor structures, settlements, and buildings have been found submerged by sea level rise and coastal subsidence. None of these discoveries have definitively proven the existence of an Ice Age maritime civilization, but they demonstrate that submerged sites exist and that exploring them is feasible with modern technology. The implications for how we think about ancient peoples and their capabilities are equally significant. The standard narrative, at least as it's often presented in popular accounts, tends to portray ancient humans as less intelligent, less capable, less sophisticated than we are. There's an implicit assumption that our ancestors were primitive, struggling with basic survival, only gradually accumulating knowledge and skills over thousands of years of trial and error. This narrative is both condescending and almost certainly wrong. Humans 12,000 years ago had the same cognitive capabilities we have today. Their brains were the same size, structured the same way, capable of the same abstract thinking, problem-solving, creativity, and learning. They had language, art, music, storytelling, complex social relationships, and sophisticated understanding of their environment. What they lacked wasn't intelligence or capability, but accumulated knowledge, written records, and the specific technologies that we've developed. But in their own context, working with the materials and knowledge available to them, they were just as ingenious and capable as modern engineers and architects working with steel and computers. The discovery of sites like Göbekli Tepe forces us to revise our assumptions about what primitive peoples could accomplish. These were not simple savages struggling to survive. They were sophisticated societies with complex cosmologies, artistic traditions, architectural knowledge, and the organizational capacity to mobilize labor for massive construction projects. They understood astronomy well enough to align their structures to celestial phenomena. They had developed sophisticated stoneworking techniques that produced monuments still standing 11,000 years later. They created art that's not just technically proficient, but aesthetically powerful and meaningful. If this was happening in Turkey in 9600 BCE, and if similar capabilities existed in Egypt during the same period as the early Sphinx date would suggest, then we need to fundamentally rethink what the 10th millennium BCE looked like. Instead of scattered bands of hunter-gatherers living hand-to-mouth, we should be imagining complex societies with social hierarchies, specialized craftsmen, religious institutions, accumulated astronomical and mathematical knowledge, and the capacity to execute multi-generational projects. These societies may not have had writing, or metal tools, or cities as we later define them, but they had something we would recognize as civilization, in the sense of organized, purposeful, creative human activity, directed toward goals beyond mere survival. The question then becomes not whether such societies could have existed, but why we've been so resistant to recognizing the evidence of their existence. Part of the resistance is institutional inertia. Academic disciplines develop paradigms, frameworks for understanding evidence, and these paradigms become deeply embedded in how research is conducted, how results are interpreted, and how new scholars are trained. Challenging a paradigm doesn't just mean disagreeing about the interpretation of specific evidence. It means questioning the fundamental assumptions that guide an entire field, and that's uncomfortable for everyone involved. Part of the resistance is also methodological. Archaeology as a discipline developed its methods and chronologies based on certain assumptions about how civilizations develop. Those methods work well for studying the civilizations we already knew existed, but they may not work as well for finding evidence of much older, different kinds of societies, especially if those societies left fewer material traces, or if their sites are in locations we haven't systematically explored. The discipline has been optimized for finding what it expects to find, which means it might miss what it doesn't expect. There's also a cultural dimension to the resistance. Modern Western civilization has a certain narrative about itself as the culmination of human progress, the most advanced society that has ever existed, uniquely positioned at the apex of history. This narrative is flattering, but also fragile. Evidence of sophisticated ancient civilizations, especially civilizations that might have possessed knowledge or capabilities that were later lost, threatens this narrative. It suggests that progress isn't linear, that knowledge isn't inevitably cumulative, that civilizations rise and fall in cycles rather than progressing steadily upward. These are uncomfortable ideas that challenge how we think about our place in history. But perhaps the most important implication of the Sphinx water erosion controversy is that it reminds us how much we don't know about the past. The confident assertions in textbooks about when civilization began, how it developed, and what ancient peoples could or couldn't do are based on incomplete evidence and provisional interpretations. New discoveries can and do overturn long-held beliefs. Technologies we didn't think existed turn out to have been used. Dates we thought were secure turn out to be wrong. Peoples we thought were primitive turn out to have been sophisticated. The history of archaeology is full of examples where experts were proven wrong by new evidence. Troy was thought to be purely mythological until Heinrich Schliemann excavated it. The Dead Sea Scrolls revealed a Jewish sect we had no historical record of. The discovery of DNA has revealed population movements and mixture we had no idea occurred. The decipherment of Linear B showed that Greek was spoken in Bronze Age Crete centuries earlier than anyone thought. Radiocarbon dating revolutionized chronology by providing objective dates that sometimes contradicted historical records. Ground-penetrating radar and satellite imagery are revealing thousands of previously unknown archaeological sites. Each of these discoveries required someone to question received wisdom, to follow evidence that it contradicted the accepted narrative, and to persist despite skepticism or opposition from the establishment. The Sphinx water erosion controversy is part of this ongoing process of discovery and revision. Whether Shaka's early dating ultimately proves correct or not, his willingness to follow the geological evidence where it led, even when it contradicted archaeological orthodoxy, exemplifies the kind of scientific courage that drives progress. The next decade could indeed rewrite textbooks, as new technologies make it possible to investigate sites and questions that were previously inaccessible. Climate change, while catastrophic in many ways, is melting glaciers and exposing archaeological sites that have been ice-covered for thousands of years. Satellite imagery and LiDAR are revealing massive structures hidden beneath jungle canopy in places like Central America and Cambodia. Underwater archaeology is becoming more sophisticated and more widely practiced. Ancient DNA analysis is revealing population histories that contradict what we thought we knew. Each of these technological advances has the potential to uncover evidence that challenges established chronologies and narratives. The Sphinx stands at the center of these larger questions about human history. It's a massive, iconic monument that everyone recognizes, situated at one of the world's most famous archaeological sites, associated with one of humanity's most celebrated ancient civilizations. If, even this monument, studied by archaeologists for over a century, turns out to be thousands of years older than we thought, created by a culture we didn't know existed, then what else might we be wrong about? What other monuments might be misdated? What other civilizations might have risen and fallen in the depths of prehistory, leaving only tantalizing traces that we haven't recognized or haven't found? These aren't fringe questions or idle speculation. They're serious scientific questions about the actual history of human development on this planet. They deserve investigation with the best technologies we have available, by the most qualified researchers we can assemble, following the evidence wherever it leads, even if it contradicts what we thought we knew. The resistance to such investigation, whether motivated by institutional protectiveness, career concerns, political sensitivities, or simple intellectual conservatism, serves no one's interests and leaves important questions unresolved. The future of this debate will likely be determined not by argumentation, but by investigation. If Egyptian authorities eventually permit comprehensive study of the Sphinx subsurface, if underwater archaeology discovers substantial Ice Age sites on continental shelves, if other monuments are found that clearly predate conventional chronologies, the weight of evidence will eventually force revision of the narrative. Paradigm shifts in science don't happen because the old guard suddenly changes their minds. They happen because new evidence accumulates to the point where it can't be ignored, and a new generation of scholars who didn't invest their careers in the old paradigm evaluates the evidence fresh and reaches different conclusions. We may be approaching such a shift in our understanding of ancient history. The discovery of Göbekli Tepe was a paradigm shock that archaeology is still digesting. The Sphinx water erosion theory, if validated, would be another. Other discoveries waiting to be made, whether in underwater archaeology, satellite survey, or analysis of sites we haven't properly investigated, could provide additional pieces of the puzzle. Within the next generation, we may have a substantially different understanding of when civilization began, what forms it took, and how it developed across the globe. What's certain is that the Great Sphinx, whether it was carved 4,500 years ago or 12,000 years ago, represents a pinnacle of ancient achievement. The monument required vision, planning, knowledge, skill, and coordinated effort to create. It has endured for thousands of years as a testament to its creator's capabilities, and it continues to challenge us, to make us question our assumptions, to drive us to look deeper and think harder about where we came from and what our ancestors accomplished. In that sense, the mystery of the Sphinx is valuable, regardless of how the dating controversy is ultimately resolved. The questions it raises about human history, about how we know what we know, about what evidence we accept or dismiss, are questions worth asking. As you drift deeper into sleep, consider this. The Great Sphinx has watched over the Giza Plateau for thousands of years, but exactly how many thousands remains one of archaeology's most fiercely guarded secrets. Whether carved 4,500 years ago by Pharaoh Khafra, Or 12,000 years ago by a civilization lost to time, the monument stands as a testament to human ambition, mystery, and our endless quest for truth. The rocks tell one story, the Egyptologists tell another, and somewhere beneath the sand, the real answer waits to be discovered. If tonight's exploration into this controversial mystery resonated with you, subscribe to Deep Sleep Documentary. We dive into history's most suppressed stories every single night. Ancient civilizations, unexplained artifacts, and the evidence mainstream academia doesn't want examined too closely. Join our growing community of 285 curious minds who refuse to accept official narratives without question. Check the description below for links to our playlist on ancient Egypt mysteries, lost civilizations, and archaeological controversies. Tomorrow night, we'll explore another mystery that challenges everything, the 97,000-year-old civilization that vanished without a trace. Until then, sleep well, dream deep, and never stop questioning what you've been told is impossible. The truth is always stranger than the textbooks admit. Good night, fellow explorers.